Picture the workflow every backend engineer has shipped: charge the car, reserve inventory, create the shipment, send the email, step 7 of 9. And right there, the process dies. A deploy restarted the pod, a spot instance vanished, out of memory. The reason never matters. What matters is that everything the process knew, which steps completed, what the API returned, which retry it was on, lived in RAM, and RAM is gone. Now the real engineering begins, and it is all mud. A status column in the database, updated after every step if you remembered. A cron job sweeping for rows stuck in processing. Retry logic that must not recharge the card it already charged. Congratulations, you are hand building a distributed state machine, and so is every other team in your company, each with different bugs. This session is about the architecture that deletes that entire category of work. It is called durable execution, and the idea is almost offensively simple: make the programs progress itself durable, so a crash costs you nothing but a few milliseconds of replay. Durable execution is a runtime guarantee, and it is worth quoting the canonical definition precisely. It ensures that your application behaves correctly despite adverse conditions by guaranteeing that it will run to completion. Read that again because it inverts the mental model. You write your workflow as ordinary code, a function with loops, conditionals, awaits. The runtime promises that this function will finish executing, even if the machine running it dies halfway through, even if it dies 50 times, even if the completion happens next week on a different continent. The business process keeps running without interruption. That is the contract. What disappears from your codebase is everything you wrote, because processes die, the status columns, the sweepers, the idempotency bookkeeping scattered across handlers. Your code becomes a state machine, and the runtime becomes responsible for its survival. A crash stops being an incident for your business logic and becomes a pause, invisible to the workflow handled below it. The obvious question is how any runtime can promise that. The answer is one of the oldest tricks in systems engineering applied at a new layer: write things down. Here is the mechanism. Layer 1, the event history. In a durable execution runtime, workflow code never touches the world directly. When your function wants something done, it issues a command to the runtime: start this activity, sleep for 3 days, wait for the signal. Each command is mapped to an event, and each event is persisted to a durable ordered log before anything proceeds. Step 1 scheduled, step 1 completed, and here is its result: timer fired, signal received. The event history is a complete and durable record of everything that has happened in the life cycle of that workflow execution. Its inputs, every decision, every result, in order. Think of it as a diary. The process keeps about itself, stored somewhere no crash can reach. The process can die, the diary cannot. And that asymmetry is the entire foundation. Because if you have a complete diary of everything a deterministic function has experienced, you do not need the process that was running it. You can reconstruct that process anywhere, at any time, which is exactly what happens next. A worker crashes at step 7. Somewhere else, a new worker picks up the offend workflow. It has two things: the same code and the event history. It simply runs the function again from the top, but with a twist. Every time the code issues a command, the history already has an answer for. The runtime does not perform the work again. It injects the recorded result straight from the log. Charge the card, already in the history. Here is the transaction ID instantly. Sleep 3 days, already elapsed. Skip. Step by step, the fresh process fast forwards through its own past, reconstructing every local variable, every position in every loop, until it arrives at the exact line where its predecessor died, and then it keeps going, as if nothing happened. That is replay, and it is the beating heart of durable execution. Recovery is not a special code path you write and pray over. It is the same code path replayed. There is a beautiful side effect for debugging too. The history is a perfect recording, so you can replay a production failure locally, step through it, and watch the exact sequence that led to the bug. Replay is a resurrection spell, and like every good spell, it has a strict condition. Given the same history, the code must make exactly the same decisions. That is the determinism contract, and it splits your program into two worlds. Workflow code, the orchestration logic, must be deterministic. No reading the clock because the replayed run happens at a different time. No random numbers, no direct network calls or database reads because the world will answer differently tomorrow. The workflow is pure decision making over recorded facts. Everything messy, the actual API calls, the database writes, sending the email, lives in activities, the individual units of work that interact with the outside world. Activities are allowed to fail, take forever, and behave differently every time because their results are recorded into the history exactly once, and replay reads the recording instead of refiring the missile. Retry is live here too, declared as policy, how often and how many times per activity instead of being handwritten try-catch pyramids. This boundary is the one real cost of durable execution. You must learn where the line is. Cross it, a sneaky clock read inside workflow code, and replay diverges. Respect it, and your code becomes immortal. Now, the evidence slide, the pattern as one production runtime documents it. Temporal, the best known durable execution platform, describes its model in exactly the layers we just built. Workflows are a sequence of steps. Your business logic defined in code, a deliberate workflows, as code stands in your ordinary programming language, not boxes and arrows in a visual editor. Activities are, in their words, the individual units of work, sending emails, making network requests, writing to a database, calling an API, the outside world layer with automatic retries based on your configuration, and full control over how often and how many times each activity retries. When workflow code executes an operation, it sends a command to the service, and commands are mapped to events which are persisted in case of failure. And the recovery story is stated with the same directness. The worker uses the event history to replay the code and recreate the state of the workflow execution to what it was immediately before the crash. Every concept from slides 2 through 5, shipping as a documented operating system, which is the point of this case study. Durable execution is not a research idea. It is infrastructure you can run today. Stay on the case study one more beat because the practical consequences are where teams feel it. First, time becomes trivial. A workflow can sleep for 30 days. A trial expiry reminder, a quarterly report as one line of code. The process serving it will be deployed, restarted, and replaced dozens of times during that sleep. The workflow neither knows nor cares because the timer is an event in the history, not a thread on a machine. Second, retries collapse into declaration. The policy, how often, how many times, with what backoff is configuration attached to each activity, and the runtime enforces it through crashes. The saga patterns and compensation logic you used to handroll become readable code again. Third, the event history is an audit log you did not have to build, a complete, ordered, durable record of what every workflow did with inputs and results, which for payments, provisioning, and compliance heavy flows is half the battle won for free. And for the engineer at 2 a.m., replaying a failed production workflow locally, watching it make each decision, is the closest thing to time travel debugging that distributed systems currently offer. This architecture is 15 years old in spirit. So why is it suddenly everywhere? Because AI agents turned every product team into a workflow team. Look at what an agent loop actually is. Plan, call a tool, observe the result, decide the next step, repeat sometimes for minutes, sometimes across days when a human approval sits in the middle. That is a long-running, multi-step, failure-prone workflow, and it has the worst possible cost profile for the crash. And restart from scratch approach. Every step is slow, every step costs real money in tokens, and the tools it calls are flaky by nature. Lose the process mid-run, and you either lose the run, burn budget, angry user, or you rebuild the hand-rolled state machine we buried in slide 1, now with prompts. Journal and replay fits agents like it was designed for them. Each tool call is an activity, recorded once, never accidentally repeated. The plan observe loop is workflow logic, replayable to the exact decision point after any clash. The pending human approval is a signal the workflow can durably await for a week. Durable execution gives an agent the one thing its intelligence cannot provide, a memory of progress that survives the infrastructure it runs on. The portable checklist, whether you adopt a platform or borrow the pattern. 1. Draw the determinism boundary before you write code. Decisions, loops, and orchestration inside, clocks, randomness, and every side effect outside behind an activity interface. Most durable execution bugs are boundary violations, and they are much cheaper to prevent than to debug from a diverged replay. 2. Make activities idempotent anyway. The journal guarantees an activity's result is recorded once, but the call itself can still fire twice around a clash edge, an idempotency key on the payment. API is still your friend. Journaling dedups retries. It does not dedupe sloppy semantics. 3. Treat workflow code as versioned, long-lived state. A workflow sleeping for 90 days will wake up in the future and its replay must run against code compatible with the history that was written. Plan your versioning story on day 1, not during the incident. 4. Keep histories bounded. A workflow that loops forever writes a diary that grows forever. Split long lives into chained executions. 5. Even if you never adopt a runtime, steal the discipline. Journal steps, not snapshots, derive state from the log. That idea alone upgrades any system you own. Landing it. Durable execution is two moves wearing one name, journal. Every command your workflow issues becomes an event in a durable ordered history, a diary no crash can reach. Replay. After any failure, fresh code reads the diary, fast forwards through recorded results, and resumes at the exact line of death. The price of admission is the determinism contract. Pure decisions inside the workflow, all the world's mess pushed into activities recorded once. The payoff is a code base where status columns, sweepers, and retry pyramids simply stop existing, where a crash is a pause, and where the audit log writes itself. AI agents made this urgent. A plan tool observe loop is precisely a long-running workflow with expensive, flaky steps. But the pattern was always going to win because it rests on the oldest truth in systems engineering, state that matters gets written down, and everything else gets derived. Next in the series, we stop waiting on the network entirely, sync engines, and the architecture behind apps with no loading spinners. Thanks for watching.